Okay guys, welcome to part 2 of the video tutorial for assignment 8. As you know, part 1 does start with a theoretical introduction into digital elevation models and the raster datasets. Before we begin, make sure that you have your assignment mark scheme in front of you. I think some previous issues with the past assignments is that you guys are not reading through all your assignment questions and answering them. But make sure you have that in front of you so you make sure that when you go through it that you answer all the questions that is necessary. So in terms of part 2, we're going to actually be dealing with conducting a slope and also contour analysis based on our digital elevation model. So that's one of the advantages of raster datasets, is that you can actually carry out many types of analysis and many model building exercises can be done with your digital elevation model. So question 2 of assignment 8 says create a high quality map or create high quality maps for contours and slope for cutting. So basically we're supposed to create two maps, one map for contours and one map for slope. And it says that a study extent must be in Gauteng. So obviously naturally, even if previous assignments we will naturally use the clip tool. Because you're dealing with a raster dataset here, the actual tool that needs to be used is mask. So it performs the same function as what a clip will do, but because it's raster dataset, we can actually use mask. To actually find your mask to come to your arc toolbox, you just put that down, and then come to your spatial analysis tools, then come to extraction, then on extraction come to extract by mask. So once you click on that, so basically it's the same as doing a clip but just for a raster dataset. So our input feature obviously is our South Africa digital elevation model, because that's what you want to cut. Then our cookie cutter will obviously be Gauteng. So obviously you want it to clip, we actually want to mask it to the extent of Gauteng, and just make sure you put your output raster dataset in the correct folder. So obviously I've created mine from an earlier exercise, so I'll just say Gauteng underscore DEM, which stands for digital elevation model. I'll just put there 2. I'll save it and click OK. Then as you can see in the bottom right here, it's extraction of my masks, so just be patient with it while the computer processes the actual command that you've given it. So once I wait for that, let's wait for it. Then as you can see, the new actual Gauteng DEM has been created. Actually switch off that that particular layer, and you can actually zoom into this layer. And if I actually switch off my Gauteng shapefiles and then the shape files, what you can actually find that the actual South Africa DEM, the digital elevation model, has actually been masked to the extent of Gauteng study area extent. So with that, you can actually now just see the different area. You can actually see the actual values in terms of your lowest point, which is 950 meters, to your highest point, which is 1,900 meters above sea level. So now the first part of the assignment requests you to actually create contours. So basically contours are lines that show areas of equal elevation. So now to do that, you come to your arc toolbox, minimize that, come to your spatial analysis, then come to surface, and then come to contour. Click on your contour. Then our input raster is obviously going to be a Gauteng DEM. Our contour interval, I know according to the assignment practical sheet it says 6, but that is actually wrong, because even though you can use 6, but the actual interval is actually too low. So for this assignment, we're going to use 50. Make sure to use the contour interval of 50 meters. So it's automatically going to save it in meters. So basically, it's going to show contour. Each line after each line would be 50 meters. So contour intervals of 50 meters. So let's make sure you save it on the right one. So as you can see, I have mine already saved. I'll just say Gauteng underscore 50 meters underscore contours. I'll say 2 time. Click save. So don't worry about the base contour or the Z factor. Click OK. And then as you can see in the bottom right, it'll start showing your the processing tool. As you can see, the contours have actually been created. So as you can see, it's a bit messy, so you can't really see anything. So let's actually start by putting labels and actually putting actual color scheme to our contours. So I'll switch off my Gauteng digital elevation model. Then I'll double click on my Gauteng contours shapefile. As you can see, it's a polyline. I'll come to Symbiology. Then I'm going to come to quantities. Obviously, I'm going to use graduated colors. And for my value, but actually before I go there, let me actually come to the attribute table so I can show you in terms of the attribute table the information it has. So for each line, so basically there's basically 2,639 lines. So each line has actual value in terms of the actual height that it's at. So our lowest point is obviously at 950 meters, and our highest point is obviously going to be at 1,900 meters. If I scroll down, will actually be somewhere in the middle even, so not so like that. So let's actually create a color ramp for this, so we can actually better seen. So I'll come to categories, actually not categories but quantities, and then for my value I'm going to choose contours, and as you can see it's created the values for the different contour height level. So let me go for 10 classes, and then in terms of my color scheme, let's use green to red. Okay. And as you can see, it shows the contours in terms of which areas have which contour lines have particularly high elevation and which ones have a low. As you can see, green quite low and red. Then let's actually add labels to it. So actually in this part of we're actually also dealing with the visualization aspect of it. We actually come to the final map. So let's come to label this feature, and as you can see the label field is actually under contours, and you can click straight for it. As you can see in the bottom left here, it's actually labeling, and as you can see it will label the actual contours in terms of different heights. So this one's 1,100, 1,100, 1,700, but you can play around with the labels in terms of labeling the feature only once or labeling the feature twice and so on. It'll be up to you. So now this is actual our contour map. So in terms of our background, when you do your actual map, you can actually if you want, you can put Gauteng, but I think what works better is actually putting the digital elevation model as the background. Then let's actually change the values of Symbiology. Let's actually change it, the color ramp, let's actually change it to green to red. Let's see how that appears, and you can click OK. Then as you can see, our contours can't be seen that much, so let's actually change the contour color ramp. Come to Symbiology, and let's change it to actually brown. The brown will work a bit better. So as you can see, it's actually changed the actual contour color ramp. And if you want, you can actually play with the display in terms of the transparency. You can make it a bit more transparent, so it's a bit easier on the eye. At least, yeah, that would be a bit better. You can actually even make it a bit more. So you don't have to choose this particular color ramp. The actual various color ramps that you can use. You can choose one which you feel best suits you. Here's a different one. Where blue is shown as on the lowest point, red is shown as the highest point. So it's actually up to you to choose which color ramp will be most applicable. So this actually completes the second part of the assignment where we're looking at contour development.